Welcome to Insight Engine Academy. In this video, we discuss some chapter and questions in the lesson Chemical Equations of 10th class. And so here is a question. 2 moles of zinc reacts with cupric chloride solution containing 6.023 into 10 to the power 22 formula units of CuCl2. Calculate the moles of copper obtained, right? So what is given in the question? We need to find number of moles of zinc is given, then it reacts with 6.023 into 10 to the power 22 formula units of cupric chloride, and we need to calculate number of moles of copper obtained. This we need to find out. For this we have to first write its chemical equation. So zinc reacts with cupric chloride solution. Zinc, I'll write zinc is a metal monoatomic, so we write symbol plus cupric chloride CuCl2 gives rise to zinc chloride, right, plus copper. This is because you see this is a solid, this is a aqua solution, this is also aqua solution, this is solid, right? Now zinc being more reactive than copper, in this case we write zinc is more reactive than copper, so zinc displaces copper from copper chloride solution and copper is displaced and form zinc chloride solution, right? And we have to balance this. One zinc, it seems it's balanced. 2 chlorines, it is balanced equation. And now let's write the stoichiometric coefficients. What quantities are involved in the question? Moles of zinc. So we write moles of zinc, right? Molecules or formula units of copper chloride, cupric chloride. So we are asked its formula units. Formula unit is synonymously used with molecules. Okay, since it is cupric chloride is ionic compound, we use the word formula unit instead of a molecule. So formula units of cupric chloride, and it is also related with moles of copper obtained. Moles of copper obtained. So let us establish. If I take according to this 1 mole zinc, what is the coefficient here? Coefficient is 1. So 1 mole zinc reacts with formula units. How many formula units? 6.023 into 10 to the power 23 formula units. Formula units. How do we obtain this? Because it is 1 mole. 1 mole of any substance contain Avogadro number of particles. Since CuCl2 is ionic compound, each particle is its formula unit. So Avogadro number of formula units. Zinc chloride is nowhere mentioned in the question, so we can ignore it for now. And moles of copper, how many moles? 1 mole copper is obtained. Okay. Now, what is how many moles of zinc is supplied? 2 moles. 2 mole zinc. Number of particles of cupric chloride is given 6.023 into 10 to the power 22 formula units. Formula units. And what is it? This number of moles of copper obtained we have to find out, right? Now from this balanced chemical equation we understand 1 mole zinc need 1 Avogadro number of formula units. If I write 2 mole zinc needs actually how much? It needs, it actually needs these are given number of formula units, but actually required is if 1 mole need 1 Avogadro number of units, 2 moles need 2 into Avogadro number, like 2 into 6.023 into 10 to the power 23 formula units are, this is required quantity. This is required quantity to react with 2 mole zinc. But in the question we are supplied insufficient amount of cupric chloride solutions. So 2 mole zinc require 2 mole zinc require 2 into 6.023 into 10 to the power 23 formula units of cupric chloride. But in the question we are provided only 6.023 into 10 to the power 23 formula units of cupric chloride, right? So the amount of cupric chloride given is less than required. This is the required quantity, and the value, the amount given is a less than required quantity, so that the any substance which is given less than required quantity is called a limiting reagent. The reactant that is less in quantity, less than required amount, is called a limiting reagent. So we write it is limiting reagent. It's called limiting reagent, and this limiting reagent decides the amount of products produced. So now the question is, the number of moles of copper is obtained when 2 moles of zinc react with 6.023 into 10 to the power 23 formula units. Now this cupric chloride decides the amount of copper that is obtained. Now from balanced chemical equation, if you see, 1 mole cupric chloride produce 1 mole copper, which means 6.023, right? Let's write 6.023 into 10 to the power 23 units of cupric chloride, CuCl2, produce 1 mole copper. Then how many moles of copper is obtained? Let us consider this is n number of moles of copper is obtained from 6.023 into 10 to the power 22 units, formula units of cupric chloride. We have to solve for n here. N is equal to 6.023, we just cross multiply, into 10 to the power 22 into 1 mole by 6.023 into 10 to the power 23. So here 6.023 ones are 6.023, 10 to the power 22 and 10 to the power 22 get cancelled, 10 is remaining, right? What is left? 1 by 10 is left. 1 by 10 is nothing but 0.1 mole. So 0.1 mole copper is obtained. This is the answer for this question. Calculate the number of moles of copper obtained. How much? 0.1 mole copper is obtained when 6.023 into 10 to the power 22 formula units of cupric chloride reacts with the excess zinc. Is it clear? This is the answer for this question. Now let us check another question. Let us see another question. 1 mole propane on combustion at STP gives A kilojoules of heat energy. Calculate the heat liberated when 2.24 liter of propane on combustion at STP. Okay. Now in this question, the chemical reaction involved is combustion of propane. So let us write the balanced equation. First let us write the balanced equation for combustion of propane. So propane C3H8 on reacting with oxygen, it burns, produces carbon dioxide and water. Okay, now I will tell you here, it's in this question we are just given combustion of propane, right? So how to identify products for combustion reaction? You see propane here, C3H8, this is a compound of only carbon and hydrogen, right? Such compounds which contain only carbon and hydrogen are called hydrocarbons. What are they called? Hydrocarbons. When hydrocarbons burn, they produce always carbon dioxide and water vapor. Okay, it can be methane. I'll write some hydrocarbons here. Some hydrocarbons like methane, ethane, right? Propane, butane, pentane, etc. Okay, etc. are called hydrocarbons. So whenever this is a biogas, we say natural gas. This propane and butane are components of LPG that we use, right? All are these examples of hydrocarbons. All these hydrocarbons on combustion produces always two products, that is, one is carbon dioxide, second one is water vapor. So these products are later balanced to find out the amount of products obtained. So now coming to this question, propane on combustion produces carbon dioxide and water, and this is, we have to balance. I write 3 carbons, 3 O2 molecules, okay, 4 H2O, then 8 hydrogens, then 3 2s are 6 plus 4 10, so I write 5 2s are 10 oxygens. This is a balanced chemical equation. Now what quantities are involved in the question? 1 mole propane. What is given? 1 mole propane. So number of moles of propane is involved here, N. Number of moles of propane on combustion at STP gives A kilojoules of heat energy. So during this, let's write it is an exothermic reaction. So heat energy is given. What is Q stands for? Heat energy, and it is an exothermic reaction, right? A joules of heat energy. Calculate the heat liberated when 2.24 liter of propane, 2.24 liter of propane, reacts with combustion, right? Reacts with on propane on combustion gives at STP. So we'll write what else given? Volume of propane is given. We are asked to find what is the heat energy produced in this chemical reaction. Okay. Now let us see first from the balanced equation. C3H8, 1 mole produce how much heat energy? The amount of heat energy produced here, A kilojoules. It is given in the question. So we write here 1 mole propane, C3H8 liberates A kilojoules of heat is produced when 2.24 liter of propane. Then we know we are given moles here and heat. So if you can take 2.24 liter of C3H8 at STP. So how many moles is this? This is given in moles, this is given in water. So 1 mole of any gas at STP, we all know, occupies 22.4 liters, right? So here 1 mole propane at STP is given, which is 22.4 liter. Now when 22.4 liter produce A kilojoules heat energy, 2.24 liters of propane produce how much heat energy? Let's say this is X. Let's find out this X. X is equal to, what is it, Nana? Let's cross multiply 2.24 liter into A kilojoules. This A can be any number. That number is not mentioned. Heat energy given in terms of A, right? Then by, what is it? It's a 22.4 liter. So what shall we cancel? A liter get cancelled. 2.24 ones are 2.24, tens are 22.4. Then X is equal to A by 10. A by 10 kilojoules of heat energy. This A by 10 can be written, what is it, Nana? It's 0.1 A kilojoules of heat energy liberated, heat energy produced, okay, on combustion of 1 mole propane, like 2.24 liter propane. When combustion undergoes combustion, it produces 0.1 A kilojoules of heat energy. If you know exact value of A, we can also express the amount of heat energy produced. This is one of the different types of questions in chemical equations. Now let us see one more question on this concept. Let us see one more question on chemical equations. We are given a question, calculate the mass volume of oxygen required at STP to convert 2.4 grams of graphite into carbon dioxide. So what is graphite? It is one of the allotropic forms of carbon. This is graphite is nothing but, what is it? Carbon here. Carbon. So to convert 2.4 kg of graphite into carbon dioxide formula is CO2, we all know, right? then what weight and volume of oxygen is required at STP to carry out this combustion process at STP. So first thing, let us write the chemical equation involved here. So let's write the answer. It's converting graphite into carbon dioxide. How do we convert carbon? Graphite is nothing but carbon. So I'm writing carbon is nothing but, what is it, Nana? It's a graphite. I'm writing carbon. Graphite is represented by C. To convert it into carbon dioxide, it has to be treated with oxygen. So it converts into carbon dioxide. C plus O2 gives rise to CO2. Now, see the question, what quantities are asked generally? We are asked mass and volume of oxygen. So we need to find out mass, like weight, and volume of oxygen required at STP to convert what is given, 2.4 grams of carbon. So mass, or we can also write this is weight of carbon, is given into carbon dioxide. Now the relation between only these two quantities, these two substances, one is graphite, one is oxygen. Now what relation asked? Weight and weight relation, weight and volume relation. We can write here, number one, two relations are asked. First one is weight and weight relation, which means weight of one reactant to weight of second reactant relation. Second one, what is it? Weight and volume relation is also asked. Weight and weight relation, weight and volume relation. Now let us check the first one. What is it? Weight and weight relation between two reactants here. So according to balanced chemical, this is balanced, right? One carbon plus one O2 molecule gives rise to CO2. This is balanced equation. And from balanced equation, weight and weight. What weight of carbon is needed according to balanced equation? This is 12 grams of carbon reacts with 32 grams, reacts with 32 grams of oxygen, okay, produce some amount of carbon dioxide. What weight? Let us also write, if it is not needed here, actually 44 grams of CO2 is produced. So we have only relation between these two reactants, right? In the question only these two reactants are involved. Weight of carbon and weight of oxygen. 12 grams of carbon need 32 grams of oxygen for completely burning. Then what weight is given? 2.4 grams. Then given weight is 2.4 grams, and what weight of what weight of oxygen is required for this. So let us write from this. Let me write 12 grams of carbon needs 32 gram oxygen. Then 2.4 kg of carbon needs what weight of oxygen? This weight we have to find out. Let's write W is equal to, before you substitute this 2.4 kg, convert this into gram. So weight W is equal to, we just cross multiply, these two are cross multiplied, you can see 2.4 kg. Kg is nothing but 1000 gram into 32 gram by 12 gram. So all are in grams. Now we can cancel out this gram here cancelled, right? Then we just convert it like let me write W is equal to, for simplification, 2.4 into 10 to the power 3. Let me write it as 24 into 10 square into 32 gram by, what is it, 12. Now we cancel out 12 ones are 12 twos are, right? Then weight is equal to, what is it, 2 times 10 square times 32 gram, right? W is equal to 2 into 32 is 64. It's 64 into 10 square gram, and this can be written as 6.4 into 10 to the power 3 gram is nothing but 6.4 kg. 6.4 kg of oxygen is required, right? We get it? When 12 grams of carbon need 32 grams of oxygen, 2.4 kg of carbon need 6.4 kg of oxygen for completely burning and producing carbon dioxide gas. Okay, now this is case 1. Let's take case 2, second, weight and volume relationship. Second one, what is it? Weight and volume relationship Okay, this is given at STP. So what weight of carbon is producing is combining with what volume of oxygen. From this balanced equation, you can see this is 1 coefficient, 1 mole carbon reacting with 1 mole oxygen. So 1 mole carbon weight is how much? Let's write 12 gram of carbon require or need what is it? 1 mole oxygen at STP, 1 mole oxygen, 1 mole not just oxygen but also 1 mole of any gas at standard temperature pressure occupies 22.4 liter of, okay, here what is it? Oxygen. So 12 gram carbon needs 22.4 liter of oxygen because it is 1 mole needed, right? Then 2.4 kg of carbon needs what volume of oxygen? This is we have to calculate. So V is equal to, what do we write? Let's write it as 2.4 into 10 to the power 3 gram into 22.4 liter by, these two are multiplied. These two are multiplied actually. V is equal to like 12 gram. Okay, now let's cancel out the units. This gram get cancelled, right? This can be written like V is equal to 24 into 10 square into 22.4 liter by 12, right? Then I write 12 ones are 12 twos are, this is, then V is equal to 2 into 22.4 is 44.8 into 10 square liter. So V is equal to, can be written, if I move this digit left side, one digit left side, so 4.48 into 10 to the power 3 liter. 10 to the power 3 liter. So it's this is the volume of oxygen required, to react completely with 2.4 kg of carbon to produce carbon dioxide gas. This is one way. You see, coming to weight volume relation, this is one way of solving the problem. There is another way. This weight volume relationship can be also solved in another way. So what is that another way? We also check it, right? So let me explain you this thing. If I take, I just keep this equation as it is, so that let me take what weight of oxygen is needed actually. The weight of oxygen needed is 6.4 kg. Is it clear? From this weight we can write the answer. What is it? It's right, volume. So this is one method. Let's say this is method 1. Method 1 for this question. There is a second method, method 2. For this, for finding volume of oxygen required. In method 2, what do? We use the weight that we calculated for the first case. First case we find mass and volume we are asked to find. First case we find mass. Using this mass we can also convert. Let's convert this mass into volume. Now let us write, what is it? Oxygen. Coming to oxygen, 32 gram oxygen, which is called 1 mole, right? This 32 grams of oxygen at STP occupies volume of 22.4 liter, right? Then what weight of oxygen we found lastly? What weight of oxygen is required to burn with carbon? 2.4 kg of carbon. It's a 6.4 kg of oxygen. So then 32 gram oxygen at STP occupy a volume of 22.4 liter. Then what volume, like 6.4 kg of oxygen it occupies what volume? So let's consider this is V. Now if V is equal to, we just cross multiply this 6.4 into 10 to the power, what is it? 10 to the power 3 gram into 22.4 liter by, what is it? 32 grams of oxygen. This is, I just write as 64 into 10 square into 22.4 liter gram. I'm writing units here, you just see. Then it is 32 gram. Here gram and gram get cancelled, liter is only remaining. 32 ones are 32 twos are. Volume is equal to 2 into 22.4 is 44.8. 44.8 into 10 square liter. This volume can be written 4.48 into 10 to the power 3 liter. Is it clear? So you see, in this case, in second method and the first method, okay, we get the equal volumes. equal volumes we found 4.48 into 10 to the power 3 liter. This is one method, this is another method. You know, in first method what did we do? Weight volume relationship we have taken. You know, if 12 gram carbon needs 1 mole oxygen at STP, we means 22.4 liter, then 2.4 kg require how much? Okay, this is we found. And second case, we just converted 6.4 kg of oxygen into volumes at STP. This is another way of solving this question. Okay, so with this problem, with this question, the chapter end questions for this lesson, chemical equations, are completed, right? See you in the next video with another topic. Thank you.